In today's video, I'll show you how to build an IoT project using MING stack with ESP32. MING refers to Mosquito MQTT, InfluxDB, Nodered and Grafana, 4 powerful tools for building IoT solutions. In this project, we'll create a real-time visualization dashboard on Grafana to monitor water levels. The uniqueness of this project is that we are not going to do any local installations for the MING stack and utilize the cloud versions of them. There is also a bonus section at the end of this video where I'll show you how to send alerts to your email if the water level reaches certain threshold values. By the end of this project, you'll have a functional IoT solution that captures water level data, processes it through a robust infrastructure, and presents it in an intuitive real-time dashboard. Hey everyone, welcome to IoT Frontier. My name is Hariharnath. Let's get started with the flow diagram. On the left hand side, you can see the water level sensor is connected with ESP32. Then the water level data is sent to Nodered, which is running on Flowfuse using MQTT protocol. In the Nodered, a flow is created to send the data to the InfluxDB. Then we connect that InfluxDB as a data source in the Grafana to create a visualization dashboard to monitor the water level. You'll also see the flow to send alerts to your email if the water level reaches certain threshold. This project is a continuation from the previous video, where I have already explained how to set up Flowfuse and visualize that on Nodered dashboard. So if you haven't watched it yet, then I recommend you to first watch my previous video from the description below or by clicking on the top right corner of this video, and then continue this video to easily follow this tutorial. I'll do a quick recap of the previous video. So we have connected the water level sensor with ESP32 and then programmed it using the Arduino IDE so that we read the values and send it to Nodered using MQTT. Then we have created a Nodered cloud instance of Flowfuse, and on Flowfuse we have created a flow to display water level values on a dashboard. So in the previous video we have also learned about LED control, but in this video we'll not be requiring that. So I'll delete that first. So to now proceed with the next steps of creating the MING stack. So right now we have utilized Mosquito and Nodered, and from this Nodered we are trying to send it to the InfluxDB first. So first we need to create InfluxDB, search Influx Cloud and click on this. Now in the InfluxDB cloud, you can see you can create your free InfluxDB cloud serverless account. So click on this. You can select any of your account. So it will ask you to provide your company name. So organization, I can keep org, company name IoT Frontier, and it will be hosting our data in the AWS. You can select any of them and click on the checkbox and continue. So because we are going to use it for free, we can just say keep this. So now you have created your InfluxDB cloud. Next thing you need to do is you need to create a bucket. So click on this and open a bucket and create bucket. So I'll use IoT bucket as a name and create. So once this is done, you need to use API token. So you need to create an API token. I'll give all access API token and I'll say all access and save it. So you need to copy this. So once you have copied this, you can close. So now come back to the Flowfuse. We need to install a module for InfluxDB. So go to manage palettes, and inside this install, try to search for Influx, and then you will find Nodered contrib Influx. You can click on install and it will install. So I have already installed it. You can check that under the nodes here. So now here I'll search for Influx. So I'll take the Influx out and connect it like this, and inside the InfluxDB I'll have to create a new server, and here select the version 2.0 and the URL. So you have created it previously, so you can just go back to the InfluxDB and copy the HTTP URL and paste it here, and the token that you have previously copied. And now click on add, and in the organization I have created it as org, and the bucket is called IoT bucket, and measurement here I am going to use as water level, and then click on done. Next you can click on deploy. So if you want to rename this, you can just rename it like Influx out, so that the node will be smaller. Now we have done the settings here. Now I'll try to program the ESP32 again. So I have connected the USB of ESP32 to my laptop, and now you can see the COM3 and ESP32 module, and you can select the port accordingly for you. Once you have done that, you can click on upload. Now the code is uploaded. I'll reopen the serial monitor and reset the program. So here after resetting, you can see it has connected to my Wi-Fi and the IP address is given, and the water level right now is 0. Now I'll place my water level sensor onto a glass of water and then see the values. So we can see the 7160 and it is increasing. Now you can go back to the Flowfuse, as well as here if you want to read that values, you can just add a debug node and then deploy it, see the debug values. These values has to be written into InfluxDB. So you can go back to the buckets and IoT bucket, and here under the IoT bucket search for water level measurement. You can remove this and click on SQL sync and select water level and click on value. So now you can see the SQL value and click on run. So you can see the graphical values. You can also see a table value as well. So next thing that you need to do is create a Grafana account, that is cloud account. Type Grafana cloud, and here you can select Grafana cloud and you can create a free account. So you can see that Grafana free account will give you these many features, and you can use any of these accounts. So I'll use Google account. So it will be asking us to set up a stack URL. So I can select that and deployment region as India and finish. Now we can see the Grafana cloud is initialized. So you can click on get started, and here you need to go to connections and click on Influx. So click on this data source InfluxDB. So you can click on add new data source, and here select Flux as a query language, and the URL you can again copy from here, and you can unselect this basic authentication, and organization as org, token you can paste whatever you have copied previously, and default bucket IoT bucket. Now you can click on save and test. So you can see 3 buckets found, which means that our connectivity with the data source, that is InfluxDB, is working. And now you can click on building a dashboard. Click on add visualization. Click on InfluxDB. So now we are taking the data source from InfluxDB, and using the Flux query language, we need to type this query so that from the bucket IoT bucket, the range of last 15 minutes, we are trying to get the measurement of water level and yield. So now once you paste this, click on query inspector and refresh. So now you can also check this last 15 minutes. So by this you will understand the values that you have seen in Flux is also shown in the Grafana. And by this way you can name the type panel like water level and click on save dashboard. So you can go back to the dashboard and you can add one more visualization. So here you can search for gauge and again search for the data source as influx and paste the query. Do the query inspector again, you will see the value, and now you need to provide the minimum and maximum value so that this can be properly shown. So the minimum value I can put as 0, max I can right now just select as 400, and the threshold I'll use 300. In the panel, I can see the current water level and save the dashboard. You can go back to the dashboard and place this tile beside. So if I want to see last 5 minutes, I can use this and just click on refresh. You can also select the auto refresh. Every 5 seconds, the refresh happens automatically. You can see that. Now comes to the bonus section of the video. Are you folks excited? Then please like this video and subscribe to the channel. Let's get started with the bonus section. We'll now see how to send alerts to the email if water level reaches certain threshold value. So go back to the Flowfuse. So first we need to determine the threshold value of the water level, in which case the email has to be sent. So for this we can consider as 300, and next we need to write a logic to check the values for the threshold and send the email. So for this what we need to do is we need to use a palette which is called, you can search for email, and here Nodered node email. This is the module that you need to install. So I have installed it and you can see that here. Once you have installed that, you need to go to the nodes here and take this switch node first, so that you can write a logic that whenever you have a certain threshold value, then only you will be triggering the email, right? So you can take this and attach it to the switch and click on switch. So you can select message.payload is greater than or equal to 300, then only we make it 1, which means that it will trigger. Click on done, and then we write a function. In this function we define what has to be sent as an email. So we connect this, and inside the function, so we paste this value where I am first defining the date value to the current date in this format, and then I am using message.topic, which will be used as a subject to the email, and message.payload, which will be the body of the mail. It will be saying warning, water level has reached, with the message.payload, that is the value in units, and then the timestamp when it has happened. So I can rename this as email function, and this as threshold logic. So after this, you need to search for email. So you need to use this email out and connect this node and double click on this email. So here you can see the two address and the SMTP server of email. Right now in this example, I'll be showing Gmail, and then you will be able to see the authentication mode and the user ID and password, which is like from address of the email. So if you are going to use a Gmail account, now you need to follow these steps. So first you need to figure out which mail you want to send it. So I'll write that in the to address, and from address I'll have to send from another account, and the password here will not be the password of the Gmail account that you have. It is a different password that you need to create, that is called app password. So how to do that? You need to follow some steps. So first go to the email account from where you want to send the emails. Click on this and manage your Google account, and go to security. Under security, first you need to clear this two-step authentication. So once you have finished this two steps verification, then only you will be eligible for creating app password. Next thing that you need to do is go to the support page of this Google, where you can see sign in with app password, and click on this create and manage your app password. So now it will show you the app passwords. So here you need to create an app that is called Nodered. Then create. So it will generate a new password for you. So you need to copy this and paste it in your notepad. And this same password can be used in the Nodered as a password, and give the name as email. Click on done. Now deploy this. Now we can monitor the values. So I'll add few more water, and now you can see one time the 495 and 303 has come. So you can go back to the inbox and immediately you can see the water level alerts. So it has reached 495, 303, 339. Every time it is reaching 300 above, you are getting this. But this will bombard your mailbox. So what we can do is, first I'll try to remove the ESP32 so that it doesn't send more values. So I can see now 18 messages has come, because every second we are trying to send the values and it is flowing above 300. So to do optimization, what we can do is we can add few processing units or nodes in the Nodered. So first thing that we can do is we can add a filter. This filter is also known as report by exception. So here we can configure a message to be sent only when value changes. So for example, if we are getting 319 and next also 319 immediately, then it will not send the message. So it will only withhold and it will send the message if it is variable. For example, 314 and then 321, then it will send a value. But if you are getting 318 and then 318 again, it will not send that value of duplicacy immediately. So by that, one thing we can assure that duplicate messages immediately will not be passed through. Get into this filter node and check the mode should be like block unless value changes, and remaining should be same, and click on done. This will only solve the problem of duplicate messages. But what about continuous messages that we are getting in the email? So for that, you can use another node called trigger. So this trigger will allow only one email with a defined time interval. For example, if I put last 1 minute, if I am getting 300 above, I'll only send it after 1 minute. So I'll connect this, and in the trigger, what I'll do is from the send, I'll use the existing message object and then wait for 1 minute, and I'll not use this extend delay and override also, and after that I'll use nothing, so that the messages will keep on sent every 1 minute only. So rename this as message limiter. So here filter you can put as duplicate filter. So once you have done this, you need to modify the existing code as well. So this code will run like this. So first we'll have a threshold logic, and then it passes through the duplicate filter, and then the message limiter. For every 1 minute only we get values to be sent, and then email. And now we are done, so we can click on deploy. So after deploy, I'll again try to connect the ESP32. So after connecting to ESP32, again we are getting 321, 330, 300 above values. So now if you check I'll delete the emails first, and then redeploy the code. So I'll redeploy the code, and you can see the messages like 324, 314. Now you should see a message only once, that is 325. So even if I refresh, I'm not getting anything. So time is 8:30:46 UTC time, and now you can see after 1 minute, I'll show you, after 1 minute you got a new message. So I can check the value as well. So you can see 8:30:46, this is 8:31:46, and the value of 304 is shown. So this is how you can even limit the messages and filter those messages in which you can send the email. And that's it. You have just built a smart water level monitoring and alerting system using Ming stack with no local installations. If you found this video informative, please type helpful in the comment section below and smash that like button. I've also created an IoT project with Ming stack using Raspberry Pi. You can watch it now from top right corner or in the end cards. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.